So yesterday's lesson we looked at graphing a quadratic in vertex form. Today we're going to take a look at graphing a quadratic in factored form. So the factored form of a quadratic looked something like before we graph a function in factored form, we have to find what are called the zeros or the x-intercepts of the function. In order to do that, we need the zero product property. And this is something you already know. If a times b equals 0, then a must be 0 or b must be 0. Now what we're going to have is a binomial times a binomial. A binomial is when you have two terms inside a parenthesis. So if x minus a times b minus x equals 0, then either our first quantity, x minus a, must equal 0, or our second quantity, b minus x, must equal 0. And then what we'll do is we'll solve to find the zeros, or the x-intercepts of our function. X-intercepts, as a reminder, are where the graph crosses the x-axis. It's also the value when y equals 0, which is why we're going to use our zero product property. And when you write your x-intercepts or your zeros as an ordered pair, it looks like x, 0. We're also going to find the y-intercept to graph our function, and that's where the graph crosses the y-axis, or when x equals 0, as an ordered pair, 0y. So we're going to find these two processes first before we learn how to graph. All right, so our first question is determining the zeros and the y-intercept of the function y equals x minus 5, quantity x minus 5 times the quantity x plus 3. So we'll find out our zeros first. Step 1, set y equal to 0, or replace y with 0. And then we're going to use the zero product property. That's what ZPP here means. We're going to solve for our two x values, or x-intercepts, using the zero product property. So what this says is if I have quantity x minus 5 times the quantity x plus 3 equaling 0, the only way to multiply to 0 is if you are multiplying by 0. So either x minus 5 must be 0, or x plus 3 must be 0. Solving each of these equations, adding 5 to both sides, and subtracting 3 from both sides, I get my two x-intercepts, which I will now write as ordered pairs. So remember, the ordered pair, the x value comes first, the y value is second. We started by replacing y with 0. So these are our two x-intercepts, or the two zeros of our function. Next, we're going to find the y-intercepts. Start by substituting 0 for both x values in the function. And let me go back here and label my work. So we've got y equals 0 minus 5, replacing both x's with 0, and then solve for your y value. Well, 0 minus 5 is negative 5, 0 plus 3 is 3, so I have a y value of negative 15. Write this y value as an ordered pair. It's our y-intercept. We started by substituting 0 for x, and we solved to get negative 15 for y. So when we graph these, we will use these three ordered pairs to help us kind of get an idea of what the shape of our parabola looks like. All right, we're going to practice this one more time before we graph. Remember, finding the zeros, we're going to set y equal to 0. And then solve for x, meaning set each term, each binomial, equal to 0. Solving these equations, solving the equation on the left, I will subtract 4 from both sides. Solving the equation on the right, I'm going to add x to both sides because it's got a negative coefficient, so that's the easiest way or the fastest way to get this solved. All right, once we have our two x values, we will write them as ordered pairs, x value, y value, x value, y value. Second piece, we need to find our y-intercept. So we substitute, sorry, I forgot to label my work again. Substituting 0 for both x values and solving for y. 0 plus 4 is 4, 4 minus 0 is 4, so we get a y value of 16. Writing that as an ordered pair, we had our x value as 0, y value as 16.